Now then YouTube, I am the Top Man. Now, today guys I've got a very different video, and I do apologise if you can't see my face. It's simply what's going on here guys. Traditional versus modern maths. Now, the thing is guys, that I've got a 9-year-old and a 6-year-old son, and both of them are obviously at school at the minute, and my eldest actually came home, he's 9 years old, came home with some homework and says, "Dad, I can't do this, can you help me with it?" And I says, "What is it?" He says, "It's maths." I says, "Oh yeah, I can do maths. It's absolutely fine, no problem at all." And he showed me his way of working out, and I had absolutely no clue. I really didn't know. Now, obviously I know my ways of doing it, and I know the way that I've done it when I was at school, and that works. That works for me, and I don't understand why the hell it's been changed. But, guys, I went ahead and I learned this new system, and I thought to myself, actually for kids it's not that hard to grasp, but still the new system just does not make much sense to me. So what I'm going to do guys in this video is just explain the old traditional system, the one that I was brought up on, and the new modern system, the one that my kids are actually going through at the moment. Now this is going to be really, like I said guys, it's really annoying for parents who want to try and help the kids, who can't help the kids because they don't know the system of what it is. Now it doesn't really take a rocket scientist to work out this new system guys, so if you are a parent or anything like that, if you just take 2 minutes of your time just to work it out, sit down, get a bit of paper or something like that, like I did, and work out this new system, it's not that bad for kids to grasp, but I still don't get why it's being used. Now the traditional system, and I do apologise if you can hear anything in the background, you know, my kids are floating around. The traditional system has always been, you know, pretty easy, pretty goddamn easy to work out. Let's do 27 times by 5. Just a nice easy one guys. Now, of course, 5 times 7 is 35. This is a traditional system. And 5 times 2 is 10, plus the 3 is 13. It's 135. That is the answer. Really easy. Now, to me, that's a system that works. There is absolutely no way and no need to change that for this new system, because it adds more steps in than what's actually necessary. This is a traditional system, as you can see here. Get rid of this. And I'll show you what the modern method is and the modern system is. It just doesn't make sense to me why they've changed it. Go ahead and wipe this off clean. The new system, guys, we'll use exactly the same thing, 25 times 7, but this time using the modern thing, which is a grid type of system, putting the 10s and the 1s in totally different places. I'll show you this. We've got our sum, which is 27 times by 5. Okay, it's a pretty easy sum. I've just worked it out. It doesn't take that long with the traditional method. The modern method, however, is, like I said, it's this grid system. So, we've got 20 in 10s, and we've got the 7 in 1s, which is the 27 from there. And we've got the times by 5, which is there. If we put this in the grid system, we've got a totally different thing here. Now this is why I don't understand why they've done it, because it's practically the same, but I just don't get it. 5 times by 20 is obviously 100, and 5 times by 7 is of course 35. And then what they do is they add them two together and you've got 135. I don't understand why they've changed that. I really don't understand. This is the modern system. The traditional system, it's done in pretty much 2 steps. All you need to do is do 5 times by 7, 5 times by 2, and then add the other ones, and then it's done. That's two sums, all done, all finished. But this new grid system is, you've got to put it in a grid first and foremost. So that's 1 step. You've got to do 5 times by 20, 2 steps. 5 times by 7, 3 steps. Then you've got to do 100 plus the 35. That's 4 steps. I just don't understand why the hell that they've changed it. But kids can understand this way, apparently, a hell of a lot easier than the other way. Can confuse them sometimes. Never confused me. You know, I got brought up on the traditional maths, and never, you know, I still know that maths now. You know what I mean? Imagine if you was in a rush and you wanted to do like a quick multiplication or something like that. The traditional method is much, much easier, and just imagine if you did that grid system in front of a customer or something at work, or it just doesn't make much sense to go ahead and do that. It actually makes more sense when you start doing long multiplication. Now, long multiplication, guys, is a little bit harder than normal multiplication, which is that 25 times 7. Let's do one from the traditional sense of long multiplication. So let's do, I don't know, 23 times by 17. Long multiplication is, of course, when you've got two tens, or when you've got hundreds and stuff like that. So 23 times by 17. Now, I do apologise, if I run out of space, I'll go over here, guys, so you can see what I'm going on about. 7 times by 3 is, of course, 21. 7 times by 2 is 14, plus the 2, you get 16. Now, because we're going on to the tens, we add a 1, we add a naught onto the end. 1 times by 3 is 3, 1 times by 2 is 2, then you add them two together, so you get 1, 9, 3. 391. 391 is 23 times 17. And if you don't believe me, go ahead and get a calculator out there somewhere. So 23 times 17, we've got that one there. That's the traditional sense of long multiplication. It's kind of a short long multiplication, but that's long multiplication anyway. Let's go ahead and get rid of this. The modern sense is very much like the original sense, like what I showed you with the single letters, with the single numbers. What was it, 23 times 17? Or something like that, I can't remember. But we'll do that anyway. 23 times 17, that's what we're going to work out. Now, we're going to put it into the grid system, of course, the normal sense. So we've got 20, and then the 3, and we're timesing that. Let's extend down here a little bit. And we're timesing that by 17. So you've got the 10, which is the tens, and the 7, which is the 7. And it's very much the same as what you do for the single multiplication, which is 10 times by 20, which of course is what I like to do, especially when I was a kid, and I still do it now. 1 times by 2 is 2, and then add the 2 noughts on, so you've got 200. 10 times by 3 is 30, 7 times by 20, 2 times by 7 is 14, plus the naught, 140. 7 times by 3 is, of course, 21. And then the new system, of course, is that you add across. So 230 plus 161. So you've got 193, 391, because of course you're adding those two totals together. So it's exactly the same. It's exactly the same answer. But to me, this way is a lot more convoluted. It doesn't make sense to me to do it this way. When you get into the hundreds, when you times 100s, guys, and we're going to do this last here, and I want to get your opinions on it. I want to know what you guys think. And I know some of you who are my audience are not of the age to know the traditional sense, or at least I hope you are within the age to know the traditional sense. If you've been brought up on the modern sense of things, then let me know. Let me know what you think, and let me know which way is the easiest if you haven't even seen the traditional methods before. Let's go into the hundreds times tables. Well, you know what I mean, the 100 times. We're going to do 121 times by 132. We might as well. Now this, it's very, very similar to how you do the ones with 2 digits. 2 times by 1 is obviously 2. 2 times by 2 is 4. 2 times by 1 is 2. Very, very easy. Because we're going on to the tens, we add a naught on the end. 3 times by 1 is 3. 3 times by 2 is 6. 3 times by 1 is 3. Now because we're going on to the hundreds, we add 2 noughts on the end. 1 times by 1 is 1. 1 times by 2 is 2. 1 times by 1 is 1. And then you add all them together. So at the bottom here, we have 2, 7, 9, 5, 1. 15,972. Let me just go ahead and put it up there. 1, 2, 1, 1, 3, 2, and then the answer 15,972. 2. Right, that to me, it's very simple. You've got simple steps: 1 step, 2 steps, 3 steps, 4 steps. Very easy, very simple. This is the argument. Apparently it's a lot easier for kids to understand the grid system and work it out that way than it is this system. But this system is a hell of a lot quicker than the grid system. So I really don't know which one you're actually... I don't know which... The argument for me, and the reason why I'm doing this video is because I don't know which way to teach my kids. I don't know if I'm meant to go along with the grid system, like the national curriculum says, or whether I can still go along with my traditional methods and show them a different way. The thing is that when it gets to multiplication, this is only multiplication. When it gets to division, sorry, this is multiplication. Division, God knows, I still haven't understood the modern way of doing division. I'm going to have a look at that. But the long division and how to do long division and stuff like that, division, is a lot different again, modern times, as it was in the traditional sense. Now I showed my lad the way that I do division. I showed my lad the way that I do division, and that's the way that he does division now. It's different apparently with the modern times, but he likes to do the traditional method because it's much easier. It's much easier to understand. Let's go ahead and do the grid system. Now this might get all over the place, guys. The grid system for 121. So that's 121 times by 132. So we'll go ahead and put this in a grid, and I do apologise if it's a little bit small, guys. We've got the 100, we've got the 20, and we've got the 1 for the 121. And then down the side here we've got the 100, we've got the 30, and we've got the 2. Yeah, I'm in there. Right, so this is pretty easy, guys. 100 times 100 is obviously 10,000. So you've got the 4 noughts. 1 times by 1 is obviously 1, and then you add the 4 noughts. So that's 10,000. 100 times by 20 is of course 3,000, because you do 1 times by 2. Oh, sorry, idiot. 1 times by 2, and then of course add the rest of the noughts on, which is the 3 noughts. And then you've got the 1 on the end. 100 times by 1 is obviously 100. 30 times by 100 is 3,000. 30 times by 20 is 600. 30 times by 1 is 30. 2 times by 100 is 200. 2 times by 20 is 40. And 2 times by the 1 is 2. And then you go ahead, add them across. So you got 10,000. You got 12,100. You've got 3,630, 242, and then of course you do that in the grid system. So we've got, let me put that in, it's all over the place. You see, I like mine in lines. So we've got 2 on the end there, 2, the 4 lines up with those 2, so it's 7. So we got rid of them, that. Next one is 200, 6, 7, 8, 9. So that, and that's gone. Then we've got the 3 and the 2, which is 5, and then we've got... So 15,972 is exactly the same answer, but to me, this is huge. This is a massive, massive way around doing the traditional methods. It makes no sense to me to do this grid system. Maybe that's because I know my times tables. If you're a kid, right, it's much easier to do 100 times 100 than it is to go ahead and do the long, the long multiplication types where you've got to do this and sideways and diagonally. It could be a little bit all over the place. To children, it could be a little bit all over the place. This might take longer, but it might be easier for them to understand. And doing long addition, like this, is a hell of a lot easier than doing it the long multiplication way, and diagonally this way and that way and this way and that way. So this is the only reason why I could think that this has actually been brought in, is so that kids can understand it a lot easier. Maybe then, when they've learnt this system, doing the long multiplication the traditional way might be, be a lot easier for them once they understand how to actually do it in the first place. But let me know your comments in the comment section below, guys, because this is one of the things what you know, he brought that homework back and I'm thinking, why the hell have they gone and changed it? Why have they done this? And I was actually quite angry about it because I thought, I can't help him. I can't help my lad this way. So I learned the new way of doing it, and then I thought to myself, actually, it possibly is the right way of going about it. I want to know what you guys think about it. Both of the ways, guys, you get exactly the same answer either which way. I don't think the national curriculum are going to turn around and mark you down for doing the traditional method of long multiplication or something like that. So I really think that it could be, you know, something that it really depends which child wants to do what. And I really hope that they do that, because at the moment, guys, and this is another thing, is handwriting within schools. You have to learn joined up writing straight off the bat. Always, every letter is joined up, every single letter. And my eldest, right, he had a hard time of doing the joined up letters. So I said to him, I sat him down and I said, just do single letters, just do the single letters. And then I got to the school and I says, look, he's struggling with the handwriting, he's struggling with joining the letters up, but he can do single letters absolutely fine. And you know what she turned around and said to me? She says, you can't do single letters. That's not on the national curriculum. You're going to have to, he's going to have to join up, because that's the way he's going to have to do it for the test. And I'm thinking to myself, what the hell is the world coming to? If this guy can write, he can write. Whether or not it's joined up or not, does it really matter whether he can join the fucking these things up or not? It really, this kind of stuff winds me up. This kind of stuff winds me up. So when they brought this new system in, and I couldn't do it because I didn't realise what the hell he was doing, it wound me up. So I learnt it. I can see reasons why, but I can also see reasons why to keep the traditional methods. Let me know, guys, what you think in the comment section below, and you know, have a good debate on this, because this is one of the things, guys, what I feel strongly about is the education of my kids and the education of what I went through when I was younger. So this kind of stuff, it means something to me. The long division and stuff like that is something totally different. I don't know the modern way of doing long division. Let me see if I can go and grab that thing. Bear with me a second, guys. I'm going to show you this long division kind of thing. I'll just grab it. Hang on. Here it is. I have it on me. Now, it says here as well, I can multiply 2-digit numbers by 1-digit numbers. And can you see this? Let me just go around here so I can see if you can see this. It says here, example, 27 times 6. I don't know if you can see that. 27 times 6 there, right? Approximate first. It's 27 rounds to 30, 30 times 6. And I'm thinking to myself, why the hell would you do that? Just do it the traditional method, you'll get the answer pretty goddamn easily. But this way, look, this is like the grid system. You've got 20, and then you've got 7, and then you've got times the 6. Oops, can't see it. 20 in the 7, and then the times the 6 there. So you've got 20 times by 6, 120, 7 times by 6, 42, and then 162. That's the answer, fair enough. But then, what the hell is this? 20 plus 7 times by 27. This doesn't make sense to me. I don't understand where they get 20 plus 7 from, and I don't see where the correlation between 20 plus 7 has anything to do with anything else in this list here. Because just take that out, it means absolutely nothing. It's exactly the same as what's over there. So why the hell have they put 20 plus 7 there? Are they trying to confuse me or what? I don't know, guys. That's the long multiplication. But let me find it here. Here it is, look. Written method for division. Look at this, guys, on the top here. Estimate. I don't know why you would need to estimate first. It's pretty goddamn obvious. 86 divided by 5. You go ahead and do the traditional methods. It's really easy to work out. But they've done it. So you've got 5 times 10 equals 50. 5 times 20 equals 100. What does this have anything to do with 86 divided by 5? I have no idea. But they go on to do 50 is less than 86. 86 is less than 100. 10 is less than 86 divided by 5 is less than 20. What the I don't get that. Unless they've done that, I really don't know. I really don't know. Anyway, you've got 86 divided by 5 equals 50 divided by 5 plus 36 divided by 5. Fair enough, you know, 50 is a whole number. It's a round number. It's something that kids will be able to understand. So you've got 10 plus 7 remainder 1, because of course 30 divided by 5 is 7 remainder 1. And then you plus them together and you get 17 remainder 1. But the thing is, I don't understand, guys. Why would you do it this way? 50 divided by 5, we know is 10. We know, as people, it's easy. 50 divided by 5 is 10, because 10 fives, 10 fives, go into 50. It's pretty easy. But this 36 divided by 5, that's a different kettle of fish. You're going to have to work out 36 divided by 5 to get the 7 remainder 1 in the first place. Why not do it so that you're just doing straight away 86 divided by 5? It's just another step that makes no sense. Again, 86 minus 50, 5 times by 10 equals 36, minus 35, where the 5 times by 7? Where does this 5 times by 7 come from? I have no frigging clue, and I really don't understand it. It makes absolutely... It's just a whole load of steps being brought into a traditional method that doesn't need to be done. In my eyes, it doesn't need to be done. So traditional versus modern maths, guys. Let me know your comments in the comment section below. I want to see what you guys think about it. Because it confused the hell out of me, and I'm 28 years old. How the hell is a 9-year-old meant to cut through all this? I don't know. I seriously don't know. Anyway, I hope that everything, was pretty clear or anything like that. I'll have a look back and make sure that it is. Now, again, let me know in the comment section what you think, guys. Go and share this on Facebook. Go and do all that kind of stuff, and we'll see what other people think about it as well that may not, be subscribed to me or something like that. I'm really not bothered if you're not subscribed to me. This is just a one-off video. I feel strongly on this kind of stuff, and I want your guys' opinions as well. I want to see what the Great British and the Great World public think about traditional versus modern maths. So until next time, guys, I've been the Toff Man as always. Stay safe.